Okay, so today we're talking scientific notation, which, if you aren't aware, is a way for us to express a really large or a really small number concisely. Okay, so I don't know, let's just say you have, I don't know, let's say that you're filthy rich and you had, I don't know, let's say you had that much money in your bank account, okay? That's an awful lot of money. How much money is that?
2,870,000,000.
Correct.
You're correct.
That's a lot of money, okay? So let's say for whatever reason you love writing down how much money you have, but you're like, oh, that's so many digits. I wish there was a shorter way for me to write this. Well, there is scientific notation.
Oh wait, isn't it with like, so you do 287 and then times like whatever?
You're close. But that first number, I'm going to give you the rules for how to do it, and then,
2.7?
yeah, you want 2.87 in this case. So, here's our rules. So, to write, let me stick with green. To write a number in scientific notation, step 1, you're going to place a new decimal after the first non-zero digit as you go from left to right. This will become second nature once you do a couple of them. It'll take me a little while just to explain it the first time. So if I do this, place a new decimal after the first non-zero digit as you go from left to right. So I start at the left of my number and I'm going to move right. The first number that I pass that's not a zero, which happens to be my first number this time, I put a new decimal right after it. So that's my new decimal. Okay, your second step, you're going to drop off all zeros that aren't between two other numbers. So I'll give you I'll give you an example of a zero that you would want to keep in a minute. So I'm going to drop off all these zeros at the end. I don't need them anymore. That number that you're left with, so in my case will be 2.87. Whatever that number is, has to be 1, between 1 and 10. So it has to be 1 or greater, but it has to be less than 10. So if you put your decimal in the wrong spot and you had 28.7, that's not correct scientific notation. So that first number, when you drop off all those zeros, that number should be between 1 and 10. Yep. Because then you could have written it more concise. Okay, so let's put a little star here.
Wait, I have a question.
Yeah.
Wouldn't all the first digit, non-zero digit would be like, wait, what if you had 0002? Can't you just drop off all the zeros? Would it be a negative? Like if it was a 4? What if you have a decimal and you want to change that? Or do you have to change it back to regular? Oh, if you had like decimal .002, you would go from like 2 to the negative whatever.
Yes, we'll get there. All right, so that new number must be greater than or equal to 1. Oh, sorry. And less than 10. If you are taking a multiple choice quiz and they ask you which of these numbers is in correct scientific notation, that's one of the first things you can check. If that first number is not between 1 and 10, it's not correct scientific notation. So if we look at our example, when we drop off those zeros, just see if I can get it all at once. Yep. My new number is 2.87. Now that you have your first number, we're always just going to multiply it by some power of 10. So I'm going to multiply it by 10 to the power of, how do you know? All you have to do is count how many decimal places are between the new and the old decimal. You don't count the number of zeros. It's a very common mistake. Okay? So, step 3, multiply that number by 10 to the power of, the number of spaces between the new and old decimal. But I'm going to add another special rule here.
Is it gonna be 2.87 times 10 to the
Ninth for us, yes.
9?
Correct. If the new decimal is to the left of the old,
There is no old decimal.
Yeah, there is. There's always a decimal.
the exponent is positive. If new decimal is on the right, exponent is negative. This seems to trip everybody up for some reason. If I'm expressing a really big number, like in this case, 2,870,000,000, that's a big number. My exponent's going to be positive. If I'm representing a teeny tiny decimal, my exponent's negative. That's all there is to it. Big numbers have a positive exponent. Teeny little decimal numbers have negative exponents. Okay, so that's really how I think of it, but that's the rule. So, if we go to finish our number, since my new decimal, did everybody write this down? Can I move it away? Oh, sorry. My new decimal is to the left of the old, so I'm in this scenario. My exponent's going to be positive. But I already knew that because it's a big number. If I'm representing a big number, what'd you say? Oh, okay.
I am still confused what the old decimal is.
Where's a decimal in a number normally?
At the end.
Yes,
You just can't see it from the center.
right. There's always a decimal in any number. Right? If I asked you to write the number 15, there's a decimal. We just never write it, but isn't it always just at the end of the number? Right. So there's my new decimal, my old decimal. So all you do to figure out your exponent on the 10 is count the number of spaces in between. So you guys were right when you said 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that giant number written in proper scientific notation would be, I'll just do it up here, 2.87 times 10 to the positive ninth.
Alan Lapierre, please report to the tech office. Alan Lapierre to the tech office.
Does that make sense? Okay, let's do a teeny tiny number. Let's do a decimal. So let's say I had the decimal. Well, now, if you're representing a little number, like this, your exponent's going to be negative. That's the only difference. Here's another way to think about it. If you always think about the number as money, if the number is $1 or more, it's positive. If it's less than $1, it's negative.
Wait, so we're gonna put the new decimal in, behind the 4.
Right. So if we read number 1, place a new decimal after the first non-zero digit as you go from left to right. So I'm going to go from left to right. The first number that I pass that's not a 0 is that 4. So my new decimal goes right there. The old decimal, this one already had one, right? There's my old. So when I drop off the zeros that I don't need, now I'm saying that I don't need, what's up with this one? I keep it. He's in between other numbers, so he stays. It's just these numbers that are either, they're called leading or trailing. So all these leading zeros, I don't need them. I'm going to drop them off away. Sayonara zeros. So my new number is 4.05. Before you keep going, ask yourself, is that number between 1 and 10? Yes. If it's not, you've messed up. It should be between 1 and 10. And it is. And then I just do times 10 to the, now, yes, it's going to be negative because that's a teeny tiny number. Then I just count the spaces. 1, 2, 3, 4, 5, 6.
Okay.
That's it.
Do you have a worksheet for us?
Well, there's a lot more to it than this. This is it for just writing a number in scientific notation. But let me try and trick you. How about the number, oh, I don't know, 325. Write that in scientific notation. You're going to follow the same steps. You have it? Go ahead.
3.255 times 10 to the
Perfect. You put a new decimal after the first non-zero digit, so there it is, 3.25. That's between 1 and 10, so I'm happy. There are no zeros to drop off, so I don't have anything to do there. That's my new decimal. My old one was back here. 325 is certainly bigger than $1, so it's going to be positive. 1, 2 spaces. 3.25 times 10 to the second. Okay, one more number. Try this one. All right, try that one. You have it already? Oh. Let everybody give it a try. Everybody wrote something down? Okay, Gianna, go ahead.
2.2, oh, no, 2.2 times 10 to the negative third. Fourth, sorry, I counted wrong.
I don't know, I might.
No, you didn't.
Third, sorry.
You're right. Place a new decimal after the first non-zero digit, so it's right there. Drop off my zeros. I get 2.2 between 1 and 10, so I'm happy. times 10 to the number of spaces between the decimals are 1, 2, 3. How did you know it's supposed to be a negative 3?
Because it's a decimal.
Yes, if it's a teeny tiny decimal, it's going to have a negative exponent. That's it. Okay, so that's writing numbers in from, by the way, do you know what it's called when you write the number out long like this? Yeah, it's just called standard form. So standard form of a number is to write it out long, and then there it is in scientific notation. Let's try going back the other way.